It's a hard topic, but we need to start. And again, two parts. This the second part, and go to more other things, because maybe you thinking in this moment I talking in the part one around maybe layer 2, layer 3 things, short security inside or micro segmentation, okay, but you need more service. So the name there is sort of the people thinking very close what is the alignment one another. Okay, topic. All cluster, Kubernetes cluster need some kind of load balancer. Normally, until this year, is ingress or route in the OpenShift platform. But now the CNSF started a new project called Gateway API. That concept is supported today in AVI, yeah? But it's Gateway APIs is an emerging technology. So it's working, it's supported by AVI, but the CNF is still working in that project. So my presentation is focused more in the ingress. But remember, ingress and Gateway API is supported both in AVI today. What is the problem? I need a load balancer, okay? Nothing more. Yeah, because it's in layer 4, layer 7 is on security, and telemetry of load, visibility. It's not just load balancer. You need a lot of things for application, including intelligent handle for the traffic, security stuff, and something very, very important, visibility or observability in the context to the cloud native application. We need that. And when you say that I need both things, the problem is starting because, okay, I can run some pods inside the cluster to Kubernetes to deliver maybe just a layer 4 and running something especially inside the cluster world to layer 7. Enough? But I need a sign, for example, and a WAF, because my application needs something for protect. But my application is created, so I need to create a DNS record. And for the application, I need assign an IP, so I need an IPAN. It's okay. No, because additionally, I have two different sites, so need load balancer. In the end, you have tools and tools and tools and tools and tools. And works, yeah, you put maybe in the 0-day work, but what happened in the day 2, at the day N, when do you need a break some parts and cross the finger for the rest of the things follow working? Because are different tools that needed some orchestration to work. And you have different projects, open source, also for this? Yes, of course. But again, works okay in the 0-day, but when you go to the natural operation, in some time you need to break something, and you need is the interoperability matrix, works or not works, it's a challenger. It's okay maybe for test an application, but an enterprise needs running today, running tomorrow. So you need to see the vision in the enterprise grade, thinking in the organization. The idea behind AVI has a lot of that source, normally for VMs, but it's possible to select the same capabilities to the Kubernetes world. And again, I don't talk only around Tanzu. It's any Kubernetes flavor. I remember yesterday I see the last update session about this topic with the AVI team, and repeat and repeat and again. It's not only for Tanzu. You have any Kubernetes flavor, it's possible to use. And when you're starting this, what is the different concept in the case of the AVI? Several projects in the CNF for load balancer and that kind create something pod inside the cluster of the Kubernetes. In that case, you compete in the load balancer with the rest of resource for the rest of the pod, the application. In the case for DBA, the load balancer by itself is running outside the cluster, running in the classic way we have it running. So you have something outside, it's possible running load balancer for VMs, and you have something special operator to see the request to the load balancer and update in the LV. Create a dynamic way for the DevOps teams, put just kubectl and then Sham5 put kind ingress, and this magic operator, AKO, see that request and push that information in the controller to ABI. Clean and transparent to the DevOps teams. That is the concept. You have something special that seeing what's happened in the Kubernetes API, and what you see request for ingress or gateway API or load balancer, take the information, import to the controller, and create the object for the load balancer. And at the same time, when the DevOps destroy that disk, taking the context, go to the controller and destroy the objects. So my mission, load balancer, is create the environment. DevOps starting to consume. I provide an easy way to consume, but using the same tool with all capabilities that I know to VMs. The idea behind is just a small operator inside the cluster to take in that information. And again, the flavor, the Kubernetes runtimes, doesn't matter. And you normally, I a developer, I create a request, an ingress or route in the OpenShift platform, it's the same concept, or gateway API now, and that request is captured for the AKO. The AKO send that information to the ABI controller, and this guy create assign IP to the outside world, create the DNS record for the application, and program that information in the data plane, the service engine ABI. And the clients just see this information, request DNS, DNS answer, go to the VIP go to the pod, the post, okay, deliver the information, and come back. Clean, transparent, in the same model you're running always ABI. But easy way to consume to the developer teams. Why? You see ABI has a lot of capacity, especially in the visibility, in the observability. You have the dashboard inside the ABI. It's amazing. You have the same tools to that. It's possible for you in the API controller create a special read-only user for the developer teams to see what happened with your application. No, you are network security. I need to see happen. Please give me a report. Easy, create a read-only user that allow access for the application, checking your own application. The same power you have in the hand for load balancer is possible transfer for the DevOps teams in the same way. And believe me, it's very common, a strong use case for the DevOps teams because the visibility behind ABI is amazing. It's amazing, especially for the DevOps teams. What happened is not a local load balancer. You remember that global load balancer. And again, ABI has the possibility of GSLB. So it's possible to export that capability to the Kubernetes cluster. Remember in the part one talking about doesn't stretch the cluster Kubernetes, and what you handle that option, you see a global load balancer. MKO is the other operator. It's possible create coordination to create in different Kubernetes cluster the information necessary to the controller create this load balancer. So without stretch the Kubernetes cluster, you have two different clusters in two different places. Place is my data center or some place where you run in the application. Kubernetes is an abstraction, and I'll be working, include public cloud. It's possible to create this information to balancer between sites with the same technology you use with the AVI for DVMs. Note, you have some information specification, CRD, for define this. Now with API, that definition is more easy. And that is one goal to change for the ingress to the new way. So go see improvement is possible to use in the classic way with the ingress or in the new way with the API. And again, you have the application because you have CSCV, the normal policy for geolocalization, for the sort of the user. What do you want to do in the CSLV is possible. The developer define, I need this capability. And you, the load balancer, define the policy. It's possible, for example, define a WAF policy. And the both teams and CRD define, I need that policy. Don't touch, name, or consume the policy. And the load balancer team still remain in control what happened with that policy. The best for both worlds. A little special thing around this connectivity and starting when you say, you remember normally the IP address assigned to the post is no routing. It's hiding inside the Kubernetes cluster. Normally, the only IP I see is the IP for the worker, normally a VM. This situation creates a special case when you need balancer and you remain in cookie style, remain the same session for the same user for the pod and not taking the car problem. I go see next, sentiment, my car, the classic doesn't state happen when you don't see exactly what happened. That happens especially when you're running in no port. No port is a way to expose to the outside world the pods. In the no port, you running some proxy, normally some IP table or Antria is possible also. And in that case, it's OBS running no IP table. Something here in all workers in the same port if exists the pod for that service or no. So you have the chance to send information to the second because you have local, but don't have control is the kube proxy prefer the other worker and the other port for the load balancer. It's no stay. It's not the stay. It's just easy way for example, layer 4. But for layer 7 load balancer, doesn't work. What is the other classical option for that case? Cluster API. Cluster API need expose, in that case, need expose the IP address in the pod to the world. Because I need load balancer to that pod, not for that, no, for that pod. So the load balancer needs to know how access on that pod, in that network pod is an abstraction running inside the cluster Kubernetes, but you have the IP address for the worker. So you see in the AKO, the automation, to create static routing inside the load balancer to see this pod, this pod, this pod is go to through the worker IP. Is possible work? Yeah. And that case, work perfect with layer 7 because it's always that pod, because I see the pod. So it's possible check the health, the classic health in the load balancer work perfect because you see the pod. But the constraint you need create that static route is automatically, but restrict indirectly connect between the workers and the data plane in the service engine. The third option is included with Antria. In that case, a mix in both cases. But in that case, you expose only the port where the pod exists inside the worker. You don't know the IP because you use a NAT, but it's a one-to-one NAT for each pod. So I see the IP worker and port and the balancer to know that case. But this is necessary to use Antria. In the other classic CNI, so Node, Antria is possible use on Calico, for example, but in that case, no port color is not exist. So usually, cluster IP is the more common use case, and you need that restriction. So for remember, you see the documentation, this is recording. If you want the picture now, you have different options to connection in the backend. So you need to go and define what is the best in each case. Okay. Repeat. It's no deep dive because everything needs a complete session. But it's just a test, taking some idea what is possible. What is the other problem? Normally, when you run an application inside a cluster, when you run this, normally you have different pods because it's microservice application. So you need to create that pod, and you need different API, a connectivity. And when they say you have IP driven, when they express in the Kubernetes world, you don't move IP packets. You move URLs, just HTTP something, APIs. The IP is nothing important, it's just the transport. So the concept to move that information is different. Really, you don't know the IP. You know the object, a pointer to something service in some place. That abstraction allows for you to create some, for example, perimeter things to deliver information. And the question here is how connect each service in between. How create different pods with different language and different libraries to handle that connection, especially if I need secure the connection, because you don't know running that. So you need inside the service that secure transport, basically encryption. And when you try starting this, you need to see a security throws all pods, doesn't matter the protocol, the library, the language, create the pods, and at the same time, visibility and compliance. For example, is it encrypted? Maybe I lost the encryption, the visibility. Can you handle both sides? See the flow transparent, but in the same time, when you go to that some far west inside the underlay, protect the information, that balancer. And of course, for example, see the compliance. The idea behind with this time success mesh is create a sidecar pod above like a micro proxy for each pod. Inside, when you're running, context. The more basic unit in the running in Kubernetes, a pod. The people thinking is a pod is equal a container. Not yet. Normally, you have one container, one pod. But it's possible in the same pod have more containers. In that case, in my use case, I have the container for the application and a container sidecar for that connectivity, and that is my pod. And again, it's transparent for the developer. The developer create the pod, and I attach that sidecar. That sidecar allows me to be, first, a common visibility, a common policy for security. Doesn't matter the library and the language used for build the pod. Transparent. And when you create that, it's possible included multiple authentication in different pods. And this multiple authentication, when you see TLS starting with the problem, with the certificate. The solution include handle the certificates, and so allow for you in an automated way deploy the application, doesn't matter what happens inside. This concept is possible to expand for different runtime environments, including public cloud, and allow connect applications with some part live in my data center, some part live in another place, so create something global namespace for the application, and poetic word, like a data center interconnect between two different clusters. Yes, it's possible create policy, what talking with who, what possible create and central management for all cluster Kubernetes running in my environment. One thing is important thing around this visibility, what happens is only TLS is allowed TCP 4443, okay, working, but I don't see what happened inside. So I lost the connectivity, but if I running a sidecar, it's possible to see for the sidecar before encryption, the traffic in text, and see maybe personal identifying information, maybe PCI DSS information, a capture. So when you, before go to real world, I see the information, I push apply compliance, is put checking that is, and then without risk put an encryption to the rest of the world. And the last, because I had short time, what happened is I combine things. I combine the load balancer for the global side with the AVI. I combine with the service mesh for Tanzu. You have options to build this. So in the same concept, you create this global side load balancer in a clean Kubernetes. It's possible to extend that concept idea included on the Tanzu service mesh. So you have options for handle this. And depend the combination is in a single zone or dual zone or wherever, what is possible combine. In that case, you have, it's possible combine with, for example, it's possible Tanzu service mesh use routed 53 in the AWS? Yes, of course, it's supported. Because routed 53 is a DNS service, AVI is a DNS service for CCLB. So both options is possible, but you starting to use AVI for different flavor, maybe for only the ingress, maybe for GLCB, or maybe for both. Last topic, just last topic. Remember when I in the first part talking about the database possible running in VM or in another format, data service manager. Today it's possible inside Cloud Foundation use data service manager, to create database running in Kubernetes. So taking all the application, include database inside the same Kubernetes environment. When the people say data service mesh, talking about, in simple way, database over Kubernetes. And it's supporting with VCF. And if you're thinking in private AI, data service mesh is the support to the vector database for RAG. See, all piece is together. I need to prepare my brain and start to consume. Takeaways. Cloud native application is not the same legacy application. You have similar concept, but you need to learn what is different in that environment. It's impossible in one shot learn all CNAPP landscape, starting small ports. Taking consume, learn, and go on the next, It's a huge. You have alignment, the different things for that works, and for course, don't build the wheel from scratch. Taking information, validate solution, you have something to starting from more guidelines for that. And again, the promotion for my friend Cormac. And thank you very much. Good. Okay.